All right, let's review all these things together, make sure we're ready for the test on this unit. So again, we're going to show all our work and thinking as much as we possibly can. It starts off with factoring out the GCF. So we take a look through here and we notice they don't have any variables in common, but we do have a 10 in each one of these. So we're going to go ahead and take out a 10. When I take out a 10, I'm left with an x squared. When I take a 10 out of a 70, I'm left with a 7. That x is left, of course, because we haven't touched that at all. And then if I take a 10 out of a 30, I'm left with a 3. So we put that in parentheses. Again, GCF on the outside, what's left of each term on the inside. If there were 3 terms here in the original problem, there should be 3 terms left inside the parentheses. So we'll take a look at this next one here. Again, notice that this one starts off with a negative, so we're definitely going to take out a negative. Let's look at the numbers. What can we take out of a 90, a 45, and a 63? Well, hopefully you recognize that you can take out a 9, so we're going to take out a negative 9. And then let's look at the variables. Let's go one at a time. So I've got 3 x's here, 2 x's here, and then 1 x right there. Remember, we're limited by the term with the fewest number of that particular variable. So we're going to take out an x. And then same thing with the y's. Notice they all have a y, so that's a pretty easy one. So we're taking out a negative 9xy. So when we take out a negative 9 out of a negative 90, again, taking out a negative turns all those to positive, so this is going to be a positive one. And 90 divided by 9 is going to be a 10. Remember, we're dividing out, we're not subtracting out. We took out the y, we took out one of the x's, so there's an x squared left. We took the negative out, so this is going to be positive. We took a 9 out of a 45, so that's going to be 5. We took one of the x's out, so that's going to be an x. And again, we took the y out, so there's no y. We took the negative out, so this is positive. Taking a 9 out of a 63 leaves us with a 7, and we took both the x and y out, so we are done right there. Next one, a big, long, ugly mess right here. So we've got a 14, a 42, and a 63. So hopefully we recognize that we can take out a 7. Leading sign's positive, so we're going to take that out. Let's take a look at the x's. We've got 2 of them here, 7 here, and 2 of them here. We're limited by the fewest number, so we're going to take out an x squared. As far as y's go, we've got 10, 2, and then just 1 over there. And then z, z, and no z's right there. So we can't take out any z's out of all of these. So z is not part of the GCF. So when we take a 7 out of a 14, we're left with a 2. Again, we're dividing out, not subtracting out. We took out all the x's, took out one of those, so we've got 9 of them left, and of course the z gets left there. And then we take out a 7, we're left with a 6, x to the 5th. We took out one of the y's, so there's a y left, and then of course the z. We took out a 7, so there's a minus 9 left. We took out the x squared and the y, so we've just got that right there. Okay, so we'll go ahead and circle that. Done with that one. Here we say factor by grouping. If there's 4 terms, we're going to try factor by grouping. Again, we'll be nice about this. The first 2 group together, the last 2 group together. So we're looking for a GCF of this group and then a GCF of this group. So in this group, we can take out a 2 and an a squared. We're left with a 2 and an a. We took out a 2 and an a squared, so the only thing left is a 1. Remember, there's always a 1 left, and that sign's important. We take out the leading sign. Please put that down there. So we're going to take out a positive, and we're going to take a 7 out of both those. So we're left with, let's see, that would be a 2a, and if you take a 7 out of a negative 7, remember there's always something left, so that's going to be a minus 1. Little hint that we did it right. We can see that common factor right there. Now, if you want to write it this way, if you want to take out the 2a minus 1 and then write down what's left in parentheses, so this is 2a squared plus 7, that's totally okay. There are people who like doing it this way. They like saying, hey, I'm just going to write that common one on the end, and then we write down the 2a squared plus 7 right there. Now, either way is totally fine. I kind of like sticking with the way we take out common factors and we put that one in the front, but either way is okay. Let's take a look at this one right here. Out of this first group, I can take a 3 and an x squared. I'd be left with a 3x. Out of this one, I'd be left with, that would be a 2. I've got to take out a negative, so I'm going to put the sign right there. And I need to take out, let's see, we've got a 21 and a 14. That's going to be a 7, so we're going to take out a negative 7. We're left with a 3x, and remember, when you take out the negative, that turns that to positive, and it'll also turn this one to positive. So we're going to be left with a positive 2 from that. I'm going to write down the 3x plus 2. We're going to pull that out, and then we're going to write down what's left, 3x squared minus 7. Got it right there. And then on this one, again, group the first 2 together, the last 2 together. So let's see what we've got here. I can take out a 5 and an n squared. I'd be left with a 5 and an n, and then a minus 3. I'm going to take out a negative, and a negative 7 in this particular case. Can't take out any variables. So I'd be left with a 5 and an n. And then if I take a negative out of a positive, again, it changes the signs of both of these. So that's why this one turned to positive. That's going to be a negative 3. Again, good hint that we did this correctly because we've got those common factors right there. So I'm going to leave the 5n minus 3, pull that out front. And then I've got 5n squared minus 7 right there. Go ahead and circle that. We'll slide down and take a look at these trinomials now. Now, when we look at these trinomials, we start off with the easy ones. So again, easy ones have a 1 as a coefficient on the squared term. When we get down here and we've got something other than that, that gets a little bit more tricky. But we'll deal with that trinomial grouping when we get there. So let's look at 7. On number 7, remember the idea here is we need to find some numbers that multiply to be 2 and then combine to be, so I'm going to write combine to be 3. Now sometimes people will write a little table and they'll do an x and a plus right here. So this is times and plus. So they need to multiply to be 2 and they need to add up to be 3. So numbers that would multiply to 2 and add up to be 3 would be 2 and 1. So what we do on this set is we just write a set of parentheses right here, and we'll put an a right here. That's the way we're going to make the a squared. And then these numbers that we came up with here, if they multiply to be positive 2 and combine to be positive 3, we're going to put a plus 2 and a plus 1. And remember, it doesn't matter if you put the a plus 1 first or the a plus 2 first. Either way is fine because of the commutative property of multiplication. So if this helps you, I'm going to go ahead and leave that right there. I'm looking at this and I need to find numbers that multiply to be 15 and combine to be negative 8. So I'm going to put a set of parentheses here and here. Again, with the easy type, we just take whatever this variable is, and when we'll put an x right here and an x right here, because when we multiply those together, that's going to make that x squared. The numbers that go here, so I'm going to write some blanks right here, they multiply to be this one right here, and somehow they've got to combine to be a negative 8. So we need some numbers that multiply to be positive 15 that combine to be negative 8. Well, again, one of those little tricks was if they multiply to be a positive and combine to be a negative, they've both got to be negative. And to get a 15, we'd have to multiply, let's see, either 1 and 15, can't make an 8 out of those, 3 and a 5, so let's do a 3 here and a 5 right there. Again, wouldn't make any difference if we had minus 5 here and then minus 3 here. This right here is the answer because these multiply to be positive 15 and they combine to be negative 8. You can, on a factoring problem, you can double check and make sure that you got the answer right. So I'll do one like this. I'm just going to multiply here and here. That's x squared minus 5x. Multiply here and here, 3x plus 15, and then these two, see how those combine? So we get x squared minus 8x plus 15. So that is the right original problem. So this is the answer, okay? So make sure that's circled. Okay, and then we'll go on. Okay, so on this one, again, easy one. I just like writing down the set of parentheses. The variable is b, so we'll put a b here and a b here. We need numbers that multiply to be a negative 8 and combine to be a negative 2. Multiply to be negative 8, combine to be negative 2. So let's see. So if we listed those out, 1 and 8, nope, can't make a 2. 2 and 4, yep, you can make a 2 out of those. So I'm going to do a 4 here, and I'm going to do a 2 here. Now remember, if it's going to multiply to be a negative, one of these has to be negative. The other one's got to be positive, and if they combine to be a negative, the bigger one's going to be the negative one. So this is going to be a negative 4 and a positive 2. Again, they multiply to be negative 8, they combine to be negative 2. So there's our answer on that one. All right, let's see, another easy one because it starts off with an x squared. Leading coefficient is a 1. Need some numbers that multiply to be negative 72 that combine to be positive 1, if I want to write that. Well, I could go through, gosh, 72, there are a ton of factors for that one, but the one that comes to mind most often for people is 9 times 8. You can combine those to be a 1, so I'm going to put a 9 here and I'm going to put an 8 here. Remember, if they combine to be a positive, the bigger one's got to be positive. So I'm going to put a plus here and put a minus right there, and there is our answer. Again, easy ones. We love those because we can just put the x here and here. We need two numbers that multiply to be 36 that combine to be 20. This is a little more tricky. So if we do 1 and 36, can't make a 20 out of those. A lot of people would guess 6 and 6, can't make a 20 out of those. 4 and 9 comes up a lot. You can make a 13 but not a 20. So 3 and 12, nope. How about 2 and 18? 2 times 18 is 36, and 2 plus 18 is 20. So we're going to do a 2 and we're going to do an 18. So we'll go ahead and circle that one. Okay, now when we get to these problems right here where the coefficient is not a 1, these are the tricky ones, these are the hard type. So in order to do this, I like multiplying these two numbers together. So 6 times 1 is 6. So we're looking for numbers that multiply to be 6 that combine to be negative 5. So I'm going to do that little chart right here. So times and add. They've got to multiply to be negative 6, and they've got to combine to be negative 5. So let's think about that for just a second. 1 and 6, 2 and 3. So there's a couple different ways that we could make a 5. This is actually kind of a tricky one because we can make a 5 with a 1 and a 6, and we can make a 5 with a 2 and a 3. But remember, they've got to multiply to be a positive 6, and they've got to combine to be a negative 5. So we could run through all the possibilities here. That's actually going to be a negative 2 and a negative 3. So double check me on this one. They They multiply to be a positive 6, and they combine to be a negative 5. Now, if you were to try some combination of this, if they were going to multiply to be a positive 6, you'd have to do a 1 and a 6, or a negative 1 and a negative 6. These combine to be 7, and these combine to be negative 7. So there's no way that that would work. So here's what we do on this. We're going to write 6x squared. We're going to use these numbers right here, minus 2x minus 3x plus 1. We use these two numbers to rewrite that middle term. That's all we're doing here, is we're turning this from a trinomial into a quadrinomial, into a longer polynomial. It's got 4 terms. And if it's got 4 terms, then we're going to use that grouping technique. And it doesn't matter whether you write the negative 3x first or the negative 2x first. It's going to work out the same way. It's just going to maybe have your factors in a different order. So we're going to take out a 2x. We're left with a 3x minus 1. We're going to take out, gosh, we got to take something out, so we can take out a negative 1. You're left with a 3x minus 1. So we've got a 3x minus 1 and a 2x minus 1. And that right there is the answer. We're all set to go. So let's slide down and take a look at this next group of trinomials to factor. Again, these are all the tough ones. Okay, so let's see. Let's multiply these together, and I get negative 6. So this is like we talked about before. They've got to multiply to be negative 6. So they've got to multiply to be negative 6, and they've got to add to be negative 5. Well, on this one's kind of cool. So they multiply to be negative 6. So 1 and 6, 2 and 3. So if we did this again, the 2 and the 3, we could make a 5 out of those, the 1 and the 6. This is a tricky one. So think about this. What if we use negative 6 and positive 1? Well, these would multiply to be a negative. And remember, if they're going to combine to be a negative, the bigger one has to be a negative. So do they multiply to be negative 6? Yes. If we add them together, do we get negative 5? Yep. So as long as we get this answer right and we're careful with the rest of it, we know we're going to get the correct answer on this one. So I'm going to break this up into the two pieces, minus 6x plus 1x minus 1. We're going to take out a 6x. We're left with a, let's see, this would be an x minus a 1. And we've got to take something out of here, so I'm going to take out a 1, and we're left with an x minus 1, because if you take a 1 out of an x, you're left with an x. If you take a 1 out of a negative 1, you're left with a negative 1. So we get and this one I'm going to go ahead and write down 6x plus 1. Again, it doesn't matter what order you write these in, and then x minus 1, okay? Now, if you want to write it with the x minus 1 here, and then the 6x plus 1 right here, totally okay. Either way is fine. Okay, let's take a look at this one. We're going to multiply the 4 and the 3 together. We get negative 12. So we want these to multiply to be negative 12 and combine to be negative 1. Yep. Okay. So let's see. Multiply to be negative 12 and combine to be negative 1. Well, that means the difference between the two numbers has got to be 1. So I'm going to use 3 and 4. But then the question is, which one needs to be positive and which one needs to be negative? If they're going to multiply to be a negative, one of them's got to be negative. They can't both be negative. And if they're going to combine to be a negative, the bigger one's going to be negative. So let's just double check here. Is 3 times negative 4, is that negative 12? Yes, it is. Is 3 minus 4 negative 1? Yes, it is. So we're going to get this right. So this is 4y squared. I'm going to do plus 3y minus 4y minus 3. Okay? So out of here, gosh, the only thing that we can take out is a y. So you're left with a 4y plus 3. The only thing we can take out of the second group is a negative 1. So I'm going to take out a negative 1. And again, it's important to write the sign and the number. So we're left with a 4y plus 3. And then notice we've got a 4y plus 3 in both of them. And then what's left is the y minus a 1. Okay, make that look just a tad better. Okay, Go ahead and circle that, and we're on to the last one. So on this one, we're going to multiply the 3 times the 6. We get an 18. We need numbers that multiply to be 18 that combine to be negative 19. Multiply to be positive 18, combine to be negative 19. Well, let's think about that for just a second. 18 and 1, you could make a 19 out of those, and they need to multiply to be a positive and combine to be a negative. So if they were both negative, negative 18 times negative 18 is positive 18. Negative 18 minus 1 is negative 19. Okay, so we're going to have 3x squared minus 18x minus 1x. I just write that in there for effect there. And we're going to be able to take out a 3 and an x. You're left with an x and a minus 6. We're going to take out a negative. There's nothing else we can take out, but again, I'm going to write that 1 there so we don't lose track of that. That's going to change the sign of that term, and it's going to change the sign of this term. Again, good news, we see that that common factor. So I'm going to write down the x minus 6 because we're going to pull that out, and then we're going to write down what's left, 3x minus 1. So we go ahead and circle that, and we're all set. Again, if your friend, you said, hey, will you tell me what you got for this? I want to see if I did this right. If they wrote it this way and you wrote it the other way, totally okay. Again, just the commutative property of multiplication there. So I'm going to slide down here and let's take a look at some simplification on this. So we want to simplify. If we can't simplify anything, we're just going to write simplified. And again, we'll assume that all the variables represent positive numbers if those happen to come up. So let's go ahead and take a look here. We've got square root of 27 here and square root of 12. Certainly those are not like terms right now, but let's go ahead and check and see if we can make those like terms by simplifying. So 27 is 3 3s. So this is going to be 3 times 3 times 3, pair of 3s. So this is going to be 33 radical 3. This is 2 times 2 times 3, pair of 2s. So this is going to be minus 10 radical 3. So this is going to be 23 radical 3. So if I have 33 of these minus 10 of these, I end up with 23 of these. Next one, I need to do some simplification right here. I can't simplify that one at all, but 125, that's a 5 times a 5 times a 5. So pair of 5s here. So this is going to be minus 4 radical 5y. 5 on the outside, that's going to be plus 30. That 5 and that y stuck underneath. So again, same root, same radicand. So if I have minus 4 of these plus 30 of these, I get 26 of these. So there's our answer on that one. And then let's take a look at this one. We're doing a multiplication problem here. We can't simplify that at all, and this is a 2 and a 7, but remember, this is that product property of radicals. We can do negative 6, and then I'm not going to multiply these together. What I'm going to do is I'm going to do 2 times 2 times 7. So there's the 2, and there's the 2 times 7 that represents the 14, pair of 2s. So we end up with a 2 on the outside with the 6, so that's negative 12 radical 7. We'll go ahead and circle that, and then we'll take a look at the other side. Okay, again, more properties of radicals here. So we've got a separate radical on the top and a separate radical on the bottom. Couple different ways to do this. Doesn't really matter which way you do it. So I'm going to go ahead and I'm going to write this as 5, and then I'm going to do a big square root with an 8 on the top and a 72 on the bottom. We can go ahead and reduce this. 8 goes in here once and 8 goes in here 9 times. So this is 5 times the square root of 1 on the top and 9 on the bottom. This is going to be, let's see, 5 on the top because square root of 1 is 1. So 5 times 1, and then the square root of 9 is 3. So the answer on this one is 5/3. Now, if you wanted to do this by simplifying each part of this, we could do it this way. That's a 2 times a 2 times a 2. So this is going to be 10 square root of 2. And then down here, let's see, this is going to be 9 times 4 times 2, because 4 times 2 is 8. So pair of 2s and a pair of 3s. So that's going to be a 6 on the outside with a 2 stuck underneath. So I'm going to cancel those off. And then I've got a 10 over a 6. 2 goes in here 5 times, 2 goes in here 3 times. So again, we end up with 5/3. So same thing either way. We'll take a look at this one right here. There's some simplification that we can definitely do here. So this is 4, and then this is 5 times square root of 16 is 4. And then let's see, we can take a 2 out. So that's going to be times 2, and we've got a 5 stuck underneath because that's 2 times 2 times 5. So we can cancel the 4s, and we end up with a 2 radical 5 on the top and a 5 on the bottom. And then again, just a quick note, can we cancel these? Can you simplify or cross-cancel the radical 5 with a 5? You can't, because that radical 5 is not really a 5, it's a square root of 5. It's about 2.2. Okay, we'll take a look at this one right here. Let's go ahead and write this underneath one big radical. So we've got a 7c to the 8th here, and we'll use some of these skills that we've been talking about. So I'm going to go ahead and cancel this. We've got a 4 on the bottom. We've got a, c to the 5th here, c to the 5th on the bottom and c to the 8th. So these 5 are going to cancel with 5 of those. That's going to leave a 3 there. So here's what we've got. We've got the square root of c to the 3rd over 4. But let's go ahead and write it as separate pieces. So this is going to be c to the 3rd over square root of 4. So we end up with a 2 in the denominator, and then we've got a pair of c's there and one stuck underneath. Okay, so this is probably the best way to write that one. Let's take a look at the next one. Again, we can do a little bit of simplification right here before we start putting these underneath the same radical. So I'm going to put a 3 out here, and then I'm going to go ahead and take out an a squared right now, because if we have 5 a's, we've got 2 pairs of a's. And then take a look at what we've got here. We've got a 7 and an a left from this one right here, and a 7 and a b left right there. Pair of 7's right there. So we're going to end up with 21a squared with a radical ab. That's what's going to be left underneath there. Now, if you see a different way to do that, or you want to put it as like a 3 and then a big square root and then do all of this underneath the same radical, that's totally okay. Lots of different ways to do these. That's the cool part. Let's take a look at the next one. So now this is surely properties of exponents right here. We're multiplying these together, so the coefficient is going to be 10. And remember, if they've got the same base, we add the exponents. So this is going to be 10x to the 12th. We'll take a look at this one. This is that power property. That exponent applies to each one of these. So we're going to have 3 to the 4th here. So 3 to the 4th, and we're going to have x squared to the 4th. Now, if you can quickly go from here to the answer, that's awesome. So 3 to the 4th is 81, and then x squared to the 4th, power to a power, we multiply those, so that's going to be x to the 8th. All right, we'll slide down, take a look at the next couple here. Again, we don't like negative exponents. We're not going to leave our answer that way. So the first thing we're going to do is we're going to move that up into the numerator, and then we're going to see if we can cross-cancel anything or reduce this in any way. So let's see, there aren't any numbers in the denominator, but we do have 7 w's on the top and 17 w's on the bottom. These 7 are going to cancel with 7 of those. That's going to leave 10 of them. So I'm going to end up with 9n to the 5th on the top and w to the 10th on the bottom. So we'll just go ahead and leave it that way. And then this is one of those where we've got a bit of an ugly mess on the inside. And let's go ahead and simplify that before we apply the exponent on the outside. So let's see, that is m to the 1st power. So that's just a 1. There's not a whole lot we can do with the coefficients. We can't really simplify those, but I can change these so that they're positive exponents. So here's what we're going to do. We're going to write this as 4 on the top. I'm going to move that m into the numerator. We'll leave that negative 3 in the denominator because there's nothing we can do about that. But we've got a negative exponent here, so let's move that n to the 4th down there. And now we'll apply the exponent. Okay, so we've got 2 4's, so that's going to be a 16. 2 m's, so that's going to be an m squared. We've got 2 negative 3's. Negative 3 times negative 3. Negative 3 squared would be 9. And then we've got n to the 4th to the 2nd, so that's going to be n to the 8th. Okay, so we'll go ahead and circle that. And then this one, again, we'll see if we can do some, well, we can't really do any simplification top to bottom yet because we've got to get those outside the set of parentheses there. So let's go ahead and apply this. So this is going to be a 16, because negative 4 squared, remember there's 2 negatives and 2 4's. This is going to be a to the 4th, and this is going to be b to the 2nd. And then what we've got here is we're going to apply this. This is a 125. And then a to the negative 2 to the 3rd is going to be a to the negative 6. And then this is going to be b to the 9th. Now we just do a little bit of cleanup. The nice thing is the numbers don't have anything in common. So I know I'm going to have a 16 here and a 125 here. I don't like that negative exponent, so we're going to move that onto the top. So that would be a to the 6th. So if we have a to the 6th and a to the 4th, that's going to be a to the 10th. 10 a's on the top altogether. And if I have 2 b's on the top and 9 of them on the bottom, these 2 are going to cancel with 2 of those. That's going to leave 7 of them in the denominator. So we'll go ahead and circle that one. Okay, so that one looks pretty good. Let's come down here. Again, on these problems on 28 and 29, what we were looking for on here is taking out the GCF to simplify this. So we're going to take out a 2, and we're left with a 5t plus 6, and the denominator is a 4. Now remember, we're not going to be canceling the 4 with the 6 or anything like that. That's part of a term. So we're going to cancel these factors. 2 goes in here once, 2 goes in here twice. So we're going to write this as 5t plus 6 over 2, and that's the way we're going to leave it. Again, we're working on taking out the GCF and simplifying, so that's probably the best way to write this, although there are other ways. Keep that in mind. And then here we're going to take out the GCF again, so I'm going to take out a negative, I can take out a negative 10 and a t. Let's see, I'm left with a 90t to the 7th. Plus a 9t to the 7th, and then plus a 6t to the 2nd, and we took a negative out, so that's going to change signs there. We're going to have a 3, and we took out the t, so that's all we've got left there. And then on the bottom is a negative 10t to the 6th. Okay, the negative 10s will cancel because those are factors. This factor of t will cancel with one of those, so that would be t to the 5th there. So here's what we end up with. We end up with 9t to the 7th plus 6t squared minus 3 all over t to the 5th. So let me go ahead and circle that, make that a little more clear there. Okay, and then let's take a look at this one. So we're away from simplifying these expressions with a polynomial on the top and a monomial on the bottom. And we've got to think about, gosh, we've got to change gears here. We're combining these together. We're adding these together. So I have 5 4 to the x plus 6 4 to the x and then plus 4. So let's take a look at this. These same base, same exponent, so those are like terms. So I have 11 4 to the x plus 4. Now again, we might look at this and think, gosh, can we add these together? Remember, that's got an exponent of 1. They do have the same base, but they've got different exponents. So this is simplified right here at this point. We'll come over and take a look at these last couple of problems. Again, we're trying to combine these together. Different bases, same exponent. Got to have the same base and same exponent. That's a constant. So this is simplified. Kind of like those. Okay. And let's take a look at this one. We've got a b to the x on the top and a b to the x on the bottom. We're going to cancel those off. 36 divided by 9 is 4, so that's awesome. Let's take a look at this one. The exponents, that exponential stuff might look a little scary, but we can deal with that. Let's take care of the coefficients first. This would be a 1 and a 6. So we know we're going to have something left in the denominator. We know we're going to have a 6 there. Let's write this as, let's write 20 over 4 raised to the x. So we're kind of using that quotient property in reverse here. So I can go ahead and cancel those. That's a 5. So this would turn into 5 to the x. Now remember, this is going to be the bigger ones in the numerator, so that's on the top. So we've kind of got this situation right here. So we have 5 to the x on the top and a 6 on the bottom. Again, lots of different ways to arrive at that. Okay, I'm going to come down here. We've got 3 more problems and then we're all done with this. Let's go ahead and take a look at this. We're trying to solve this one for m. We want to get m by itself. Well, this is m times c squared, so let's just divide by c squared. So we get m equals e over c squared. Circle that, we're done. And on this one, what we're going to do is we look at this, we've got to get the b1 by itself. One thing we could do is we could distribute these through the set of parentheses. But if we can clear that fraction, that's going to make our life a little bit easier. So we multiply by the reciprocal of that fraction. So we're going to multiply this side by 2 and multiply this side by 2. So we end up with 2a equals, I'll need a capital right there. So 2 times capital A, this is going to be b1 plus b2. And then we multiply that by h. Now we could distribute through the parentheses to get rid of it that way, but we could also just do this. Let's just divide both sides by h. That's going to cancel that off, so we have 2a over h equals b1 plus b2. And then at this point, all we need to do to get the b1 by itself is just to subtract the b2. So we'll subtract b2. So here's what we get. We get b1 equals, we have 2a over h minus b2. And we can go ahead and circle that. Now, that is not the only way to write the answer. There's a couple different ways that you could do that, but that's one way that you could approach it. Now, let's take a look at this last one. I'm going to zoom in on this one because this one asks us to solve for a. And you'll notice that there's an a on both sides. So I'm going to go ahead and draw a line here. If I want to get the a by itself on one side, I first need to get it on one side. So I'm going to add AD here, add AD. So I get B equals AC plus AD plus E. These are the two A terms. Whoops, that's an E. So I want to get rid of the E Okay, so we'll subtract e from both sides. So I have b minus e equals ac plus AD. Now, this is one of those tricky ones because we've got to get that completely by itself, and we have two a's here. Well, the way we make it look like there's one a is we factor out the a. They both have an a in common, so we're going to take out an a. We're left with c plus d, and then on this side we still have the b minus, whoops, keep writing c, b minus e. And then this is one entire factor. That c plus d, you could think of that as a single number. We're going to divide by that quantity. In fact, that's a lot of times why we use the word quantity. So this is the quantity c plus d. We're going to divide by that quantity c plus d. Cancel those off, so I'm going to get a equals, and then we've got b minus e on the top, and then we don't really have to write the parentheses on there because they're just grouped together anyway by that fraction bar. So this is c plus d, and I'm going to make that e look really nice. Okay, all right, there you go. That is the entire practice test. If you can do that, you should be in really good shape for the test on this. Again, really good review of skills in this unit. The factoring is really going to come in handy. There's nothing in here that you're going to say, oh, we didn't really use that. Really good skills on this one. All right, good luck on the test.